In today's lecture, we are going to see evaporation control methods and dam instrumentation. This is from unit number 6 of your subject dam engineering. So let's move. So what are the various methods of evaporation control? See, there are several methods which are design parameter, then floating covers, chemical coating, then windbreakers and shades. The first control method, that is design parameter, it needs to be adopted when you are constructing the dam, when you are designing the reservoir. Okay, then the remaining four methods, which are floating covers, chemical coating, windbreaker and shades, can be adopted later on after the complete finishing of reservoir. After complete construction of dam, you can adopt the remaining four methods, but the first one needs to be taken care of when you are in the design stage of your dam and the reservoir. Okay, let's see the each method of evaporation control one by one in detail. So design parameter are saying we should adopt more depth to area ratio. In short, the depth of the reservoir should be more. Okay, it should be deep and it should have least exposed surface area. Now what least surface area is going to cause? It will cause less exposure. It will be having less exposure to wind, dry wind, draft. That's why evaporation the quantity of evaporation that will be taking place in such reservoir will be less. Whereas if you provide more exposed area and if the depth is less, okay, let's say these two reservoirs having the same quantity, but one of the reservoir is having less exposed area and one of the reservoir is having more exposed area. What is going to happen? The reservoir which is having more exposed area will be prone for more quantity of evaporated water. And another method we can adopt is cellular construction of reservoir. Okay, this thing also be need to taken care of when you are designing the reservoir. Okay, it cannot be done later on. For example, if we are having this number of cells in the reservoir, what is going to happen? The cell boundaries are going to act as barrier for the wind. Okay, and therefore the motto of having more depth and less area will be accomplished when you are dividing the whole reservoir area into number of cell, into number of individual grid. Okay, this is the design parameter and you have to provide the required design parameter in order to have less amount of evaporation when the dam and reservoirs are in phase of construction. All right, let's move to next method, which is floating cover. See, these polyethylene sheets and balls can be totally covered on the reservoir provided that the material from which the sheets or balls are being made is not dissolvable in water. Okay, it should not emit its color, it should not get dissolved in the water, it should be free from any toxin means any toxic compound. Okay, otherwise you can have a wax coating or foam layer which will be there on the reservoir, but the problem with wax and foam is that you have to make sure that the total reservoir area has got covered with wax or foam, and they need to be properly maintained. The wax cover and the foam cover need to be properly maintained so that they are not having any loophole on the reservoir cover. Okay, then chemical coating. Two chemicals are there, cetyl and dicyl alcohol. They can be poured on the surface of the reservoir. Okay, we can procure barrels of the cetyl and dicyl alcohol and we can pour all the chemical on the reservoir surface. What this thin sheet will be doing, this thin sheet of chemical will be restricting the sunlight to take away the water moisture. Okay, therefore the rate of evaporation will be totally eliminated, but this get sublimated, this get vaporized in the atmosphere. These chemicals are prone to sublimation, or let's say the proper word is evaporation. These chemicals are also prone to evaporation, therefore after a cycle of 4 days they need to be poured in a cycle. Okay, they need to be poured periodically, otherwise they totally get diminished and the evaporation process will initiate in the reservoir. Okay, then windbreakers. Now see, the problem of evaporation is there because of two factors: temperature is there and dry wind is there. One thing can be done, that the whole area can be covered with some surface, and other thing can be done that we can stop the dry wind draft to enter our reservoir surface. Okay, when you are stopping the wind, when you are stopping the dry wind, it will not be able to carry the moisture away from the reservoir. Okay, what wind does is, wind flows over the reservoir surface, is absorb the moisture from the reservoir and it takes it away. Okay, but if you totally have a compound barrier over the reservoir, then what is going to happen, there will not be any evaporation. Okay, and here you can see the artificial windbreaker. The artificial windbreakers are such that they act as shade or cover also, and they do not allow the wind to take away or to carry away the moisture. Okay, these are what windbreaker. Then shades, the basic, the most dumbest, if we can say, the dumbest solution of restricting the evaporation is to cover the container in which the liquid is stored. Okay, then we can adopt a fiber panel or solar panel shade when the reservoir size is small. Okay, having a solar panel as a shade for evaporation control has the added advantage that you can have solar farming over there. You are having the added benefit of solar powered electricity over there, and also the water is not getting evaporated from the reservoir. Okay, means having shade, although it is costly, although it is having some sort of maintenance, some sort of periodic maintenance will be there, and initial budgeting will be very high, but still the added advantage is that if we are adopting solar panel, then the space is very much being utilized in a proper manner. Okay, now let's move to another part of the PPT, which is a dam instrumentation. Now what instrumentation is? Okay, the word itself is suggesting that dam instrumentation is saying that we should have some instruments fitted on the dam, inside the dam, on the surface of the dam. Now why we are providing this instrument? What is the need of instrumentation? Let's see into that. A manual, okay, what dam instrumentation is? A manual, electronic, mechanical, optical, hydraulic and pneumatic device fitted so as to measure, assess, record and display engineering parameter. Okay, in order to judge some engineering behavior, engineering parameter of a structure such as dam, we are focusing on dam here. So to judge some parameter, we are going for dam instrumentation. Okay, a manual instrument may be there, such as inclinometer is there or clinometer is there. Okay, survey instrument is it is. Then electronic, some IC chips may be there. Okay, then mechanical, some spring loaded action tools may be there. Okay, then optical, some methods of survey which are used for assessing the dam health are also used. In that we are going to use the leveling survey, and for that optical tools may be used. Hydraulic tools are there, piezometer will be there, pneumatic devices means pressure measurement cells will be there. Okay, and these devices are fitted so that we can measure, assess, record and display, also analyze the engineering parameters, the engineering behavior of the dam. Then what an instrument consists of? It comprises of three things. A sensor will be there, and whatever the data the sensor is sensing, it will be signaled via a media. Okay, a signal conducting media will be there, and a display unit will be there, which is called as a readout or a recorder. Then what is the purpose of dam instrumentation? Why we are carrying out dam instrumentation? Purpose of dam instrumentation. The first thing is safety of dam. Whether the dam is safe or not, whether it is ensuring the safety parameter or not, can be assessed, can be quantified, can be qualified only after we are fitting some gauges, dial gauges or instruments over there. Then health monitoring. Regular health monitoring of the dam means structural behavior of the dam can be checked only when we are fitting some tools over there. Okay, then prevention of failure. In case we are finding out that the behavior of dam, the structural behavior of the dam is not within the limits, is not within the predicted limits, then we can carry out some preventive measures over there. Then avoidance of catastrophe. See, in case in the last scene, if the dam is going to fail, some catastrophe is going to take place, then we can rehabilitate the people surrounding the dam, we can evacuate the total area, and then if the dam is ultimately failing, then we can avoid the loss of man, loss of men, loss of property, all the things can be avoided. Okay, the event of dam failure turning into a catastrophe can be totally avoided only when we are having the proper dam instrumentation methods fitted over there. Then comparison of actual behavior with predicted behavior. Even before the dam is being constructed, we are having certain parameters within which the dam should act. If it is behaving outside the parameter, if it is exceeding the limit, then we are saying that the dam is not performing, the health of the dam, the structural health of the dam is not proper. And in order to assess this specific thing, we should have a proper instrumentation kit. Okay. Then refinement of design of existing dam and future projects. See, if we are fitting the proper instruments on an existing dam, and from the instrument we are going to see a specific behavior. If it is gravity dam, it is masonry dam. If it is a earthen dam, if it is a rockfill dam, each specific type of dam will be exhibiting some properties over there, and these properties can be recorded, can be assessed, can be analyzed, and the same set of properties can be predicted for current construction or some future construction. Okay, and if these properties are not behaved well by the existing dam, then the proper refinement of design can be done for existing construction and for whatever the future avenues, the future project that are going to be held in the near future. Okay, so this was the last point regarding dam instrumentation purpose. So let's see what extent to which we carry out the dam instrumentation. Okay, in that there are several points. The dam instrumentation extent means how much instrumentation kits, what is the quality, what is the amount of kits of instruments should be fitted over there. It depends on several parameters, means how many instruments we should use and how much the qualitative index that is provided by the tools should be there. The hazard to life and property that the dam present. For example, if a dam is located near to civilization, then more number of instruments should be there, more health checkup, then more cycle of checkup of structural behavior of dam should be taken. Then height or size of the dam. More the height, more the size of the dam, more the massiveness of the dam, then more instruments will be required. The extent of instrumentation will be more. Then the volume of water impounded by the dam. If the reservoir capacity is very large, then we should take care that proper and exact number of instrument required should be fitted over there. Okay, adequacy of instrument should be there. Then seismic risk at the site. For example, if the dam is situated in a seismic zone which is prone to earthquake waves, then the seismograph and all the required instruments should be fitted over there. Then age or condition of the dam. See, if the dam is old and prone to failure, then the number of instrument, the quality of instrument being fitted over there should be good. Okay, then the frequency and amount of water level fluctuation in the reservoir. See, in an area which is surrounded by mountains, then the frequency of change in the level of reservoir will be there. More reservoir emptying and more reservoir filling up process, if these specific cycles are more, then the proper instrument should exist over there. Then the history of problems or abnormal behavior at the dam. If the dam is not behaving in the predicted behavior set, then we should have the proper instrumentation kit fitted over there. Okay, now let's see what are the various parameters that needs to be checked by using the dam instrumentation methods. Okay, let's see the parameter. The first parameter is water pressure. Either it may be seepage pressure or it may be the load of water which is coming from the reservoir water ponding. Okay, then seepage and leakage through the body of the dam. Then movement of the dam. Movement implies to the horizontal movement of the dam and vertical means settlement of the dam. Then the reservoir water level, the amount of water in the reservoir can be measured when we are knowing the proper level of reservoir water. Then weather condition, the evaporation rate, the rainfall rate, the snowfall rate, if it is located in a snowy region, snowfall region, then all these natural parameters, even wind velocity, temperature, all these parameters come under weather condition. So these needs to be measured by using the instruments. Then local seismic activity. Yes, seismographs may be used for determining the tremors in the soil because of earthquake. Then temperature, okay, temperature of the dam body, temperature of the water in the reservoir, all these things need to be measured, and for that the simple device thermometer is used. Okay, now see, the first parameter is water pressure. For measurement of water pressure, we are going to use a piezometer or standpipe. Piezometer are a device used to measure the water pressure at specific location in dam bodies or foundation and abutments. And the primary value of water pressure data is to warn certain condition or problem that may exist or may be developing. Now, what happens in a piezometer or a standpipe piezometer? See, for example, if this is a level, this is a floor which is being exerted upon with some water pressure. Now what the standpipe or piezometer does is, it has a hole on the floor and the standpipe is located somewhere here. Now whatever the amount of pressure which is being borne by the floor will be reflected in the piezometer. Okay, all the pressure data will be reflected in the standpipe or in piezometer. By this assessment, we can have a proper knowledge of what is the seepage pressure, what is the, sorry, not seepage pressure, what is the uplift pressure which is being exerted on the foundation or on the dam body or on the abutment of the dam. Okay, then seepage and leakage. Seepage from reservoir is the interstitial movement of water through a dam, the foundation or the abutment. Seepage is different from leakage. Leakage is the flow of water through cracks or holes which are present inside the dam. Okay, seepage and leakage through a dam should not be large enough to erode the material from inside of the dam body. Okay, the problem with seepage and leakage is it will be carrying, seepage and leakage is continuous, and what this problem will be doing, it will be carrying away the particle of the dam. Okay, either it is, if it is concrete dam, then it will be taking away the concrete particle, it will be taking away the grains of the material of the dam, and thereby the widening of the crack, the widening of the hole will take place, and it is going to expand exponentially. That's why we should have a clear attention toward the amount of water which is going via seepage and leakage. Okay, wherefore seepage flow measurement can be used as a device, then laser Doppler velocity meter. Okay, velocity and quantity of water which is going via seepage and leakage are directly proportional, therefore more the velocity that will be observed by the laser Doppler velocity meter, thereby we can conclude that the seepage amount, the leakage amount is very high. Okay, now let's see another parameter, movement. Now when we are talking about movement of the dam may be in horizontal direction as well as or vertical direction. Okay, horizontal direction means if the dam is getting displaced because of the reservoir water force, hydrostatic force, then it will be the horizontal movement, and if the dam is going to settle, if it is settling, then the vertical movement will be there. Okay, and for that we are having several methods, such as we can carry out a survey in order to determine the horizontal as well as vertical settlement. We can conduct a survey in which what we are going to do, we will be having a fixed monument, and over that monument we can fix our survey instrument, and that survey instrument will be used first when the dam was just completed, and after a year, after 6 months, after let's say a year, after 5 years, we will be carrying out the same survey, and the initial records that we had while we had the first survey will be compared with the readings that we took after 5 years, let's say, or 10 years, let's say, and difference in between them should be within the desirable tolerance limits. Otherwise we will declare that the dam is settling or the dam is moving away. Then we are having this plumb line method, in which the upper structure of the dam and lower structure of the dam are connected by using a plumb line, and the 2 points of the plumb line show a linear relation. Okay, they are in line with each other, and if after some year if we find that the two lines are not in line with each other, then some sort of movement has taken place inside the dam body. Okay, and some settlement may be there. Okay, thereby several methods are there in by which we can determine the movement, even by carrying out the photographic survey. We can determine whether the dam has moved from its very position or not. Okay, Then reservoir water level. This is the simplest measurement we can take. We can have a stop gauge. In the diagram, you can see a stream is there and a stop gauge is there. When the stream water level increases, you can directly see what is the level of water inside the stream. Same way in the reservoir, we can have this column, this pier, and over this column, the graduations are there in meters or let's say centimeters. Okay, for fine reading, centimeters may also be calibrated on the column or on the stop gauge. This is the simplest measurement that an engineer takes in the dam body. Then weather condition. Weather condition means precipitation in form of water, let's say rainfall or snowfall or hailstorm or whatever it be. Then what is the wind velocity? Windrows diagram may be generated for the specific region of the dam. Then evaporimeter may be used in order to determine the rate of evaporation of the dam. Then rain gauge meter, then snowfall gauges may be used in order to judge, in order to assess the amount of rainfall received during a season, over the span of year or a decade. Okay, weather conditions are also a long term parameter that needs to be taken in consideration for health checkup of the existing dam or for future project that may be taken inside the region. Okay, then seismic activity. The seismic activity or the local seismic activity can be determined by using seismograph. See, when you are installing a seismograph in a dam body, it will be continuously showing some vibration. Okay, but those minor vibrations do not play a major role in disturbing the dam structure. When the vibrations are so much that they are going to cause some failure of the dam, then such reading should be continuously noted by the seismograph. Okay, and by knowing the seismic zone, by knowing the previous history of earthquake, we can take care of the failure, the seismic failure of the dam, and for future project, for future avenues, we can have the proper arrangement during the design and construction of the dam. Now temperature, the simplest one is the temperature. You can use thermometer in order to assess the temperature stresses that are going to take place in the dam body and also the temperature of the reservoir. Although temperature of the reservoir does not play a major role, only the upper zone of the reservoir will get heated up because of sunlight. But when we are talking about a massive structure such as dam, then a minor temperature change cause large extent of temperature stresses inside the body of the dam, which may prove fatal to the health of the dam. That's why temperature is also another added parameter. So that was all regarding control of evaporation and dam instrumentation. Stay home, stay safe, take care, bye.